So Robert Boyle defined relationship between pressure and volume. So now Charles did define relationship between volume and temperature. So remember 4 variables that affect on gas: pressure, volume, temperature, and number of the moles of gases. Okay. So Charles decided to find the relationship between volume and temperature. What he did, let's say, I'm trying to explain with this, and that's a piston and cylinder assembly, for example. Then he put some amount of volume of the gas, and then he heated on a hot plate, or maybe consider hot plate or Bunsen burner. Okay, at I would say 273 Kelvin, and then let's say he increased temperature from 273 to increase up to 500 Kelvin. Kelvin. So through that observation, you can see that if temperature increase, what happened to the volume of the gas inside? Volume also increase. This is temperature, so volume also increase, right? So that is a direct relationship. Volume and temperature, they are directly related. So this guy manipulated between volume and temperature, but what he did? He kept pressure constant for both conditions. Pressure constant, same. So he said, I will keep this one constant and manipulate these 2 variables. And that's where he found direct relationship between volume and temperature. One more condition he did. He said temperature should be in Kelvin. In Kelvin scale. So whenever we calculate Charles' law, we need to convert temperature in Kelvin. That's where this law applies. So it should be in Kelvin. And the mathematical relationship he came equals V equals KT. This is a constant. This is temperature in Kelvin, and V is volume. And for 2 conditions, he said V1 over T1 equals V2 over T2. So that's mathematical relationship he came with it. Now, graphically, I'm going to explain how it looks graphically. I'm going to go to next slide. He said, okay, volume and temperature and direct relationship, right? It's a direct because one increase, other increase, one decrease, other decrease. That direct relationship, so it's a straight line graphically. Okay, so now let's work on one example on Charles' law. Okay, so a sample of nitrogen gas occupies a volume of 250 milliliter at 25 degree Celsius, what volume will it occupy at 95 degrees Celsius? Now, we know that this is 250 milliliter, we consider as a B1. This is T1 and that's a T2. We need to find out V2. The first condition, we need to convert temperature into Kelvin. So 25 plus 273, so which is 298 Kelvin. T2, 95 plus 273, so you need to find out Kelvin. Okay, V1 is 250 milliliter and V2 we need to find. Now we know this equation. What equation? P1, V1, no, sorry, not that equation. We are going to use Charle's law. V1 over T1 equals V2 over T2. And in that case, we need to cross multiply. So we can say V1 T2 equals V2 T1. Here we rearrange V2 equals V1 T2 over T1 and then we plug the values. Can you guys tell me what's the T2 when you add them together? 273 plus 95. Huh? What do you guys got? 368 Kelvin. Okay. So now we have T1, T2 and V1. So we plug that in this equation. So we can say 290, 200 and, no, first we need to plug in V1. So we have 250 milliliter times 368 Kelvin divided by 298 Kelvin. Okay, let me erase this so you guys can see it much better. Okay, now in this case, Kelvin cancels. You can calculate volume, and when you calculate volume, you get about 310 milliliters. So that's new volume sample of nitrogen gas. So that's Charle's law.